enlargement. Okay. These are our 4 types of transformation. So at the moment, these are just words. I'm not entirely sure what they mean yet, but perhaps you have heard some of the words before. Okay. So a translation, this is not a English to French translation or something like that. This is a translation in mathematics. Translation is a move. So usually key thing to say about it is moving shapes. And we move shapes left and right, and up and down. Okay. So a little sketch example of that is move that triangle to over here, goes right and up. That's a translation, it's called. You just slide it over and up. So if I translate this page, I can move it around on this 2-dimensional surface. And then it will hopefully refocus again. All right, so that is a translation. Just going to put a line here just to talk about reflection next. Now, if you don't, maybe your notes don't fit across a page like this, you're more than welcome to arrange this whatever way you want, or if you've written it the same as me, that's obviously fine as well. A reflection, the most important thing about a reflection is that we have a mirror line, something that we reflect a shape. So this is all about moving shapes or points. So a mirror line is where we reflect, possibly, where we reflect the shape in. So if we take a shape like this, just a triangle like that, and if it looks at itself in the mirror, well, what would it look like? Well, it would have to fold perfectly over the mirror, so it would look like that. It would look at itself in the mirror. It's a bit like when you, so it's kind of backwards when it looks, a bit like when you look at yourself in the mirror, and then you've got your left hand or right hand up, your mirror image has got the opposite hand up. Okay. So that is a reflection in maths. So we'll go into each of these in more detail, but I'm just giving an introduction. Rotation is, I suppose, spinning an object. You know what a rotation is. So you can either spin it on the spot, or you can spin it around a point. So I want to spin this shape around this point, and this requires a bit of extra work, but it's spinning around this point, so it's turning around. So you can turn clockwise or anti-clockwise. And an enlargement then, well, you probably think about what this one might be. It's getting bigger or getting smaller. It's both called enlargements. Increasing or decreasing the shape size, and that depends on a scale factor. Oops. Okay, so if the original is small, and then the scale factor is to say 3 times bigger, this will be 3 times bigger. So go from there to there. This is the original. This is what's called the image. Now you can see that all of these, there's an original, and then there's an image. The original is called the object, so you can draw it on any one of these. Maybe this one. The object is here, and it's the original is called the object, and the other one is called the image, and that's the same for all of these. Object, image, object, image, object, image. Okay, so that's our initial introduction to all of these, and I'll give you a minute just to maybe tidy up your notes there, maybe highlight some of the titles and stuff. So I'll give you another minute if you want to finish off your note. Does anyone need more time?
I do.
Okay. Okay, I'll move on. If you didn't quite get the note down, I'll have the recording up at some stage this evening. All right, the next thing we're going to look at is the Cartesian plane. Now, you almost certainly have done this before, and perhaps it's called a different name when you did it. Some people call it a coordinate diagram. Or an XY axis or something like that. It's where the two number lines meet, and we can use them to form coordinates. So this is where you'd need to get out your ruler. Draw a nice line vertically and one horizontally. Okay. And you use the dots in your, or the squares on your math book. I'm going to use just centimeters here to mark it off. So I am kind of assuming that you guys have done this diagram before. Maybe you haven't, but we're going to go through it anyway. Yeah, you should have done it. Okay. All right, and these are just two number lines that intersect at 0, 0. Yeah, you should have done it in map reading and stuff, yeah. Does anyone know what this is called, this line is called? There's a special name for this line. Nobody? Okay, it's called the x-axis. Oh yeah, you got it. X something, yeah, it is the x-axis.
I was about to say that, but then I didn't know.
Okay. And that means this one up here, this one, the vertical one that goes up and down, is called the y-axis. So I'll give you a second just to, well, no, I'll put in numbers first because they are just number lines that intersect at both their zeros. it is important that these spacings are the same. So if you're drawing your axis, that your gap from 0 to 1 is the same from 1 to 2 and so on. That, otherwise your scaling is going to be off. Mine probably isn't perfect because I did it in a rush, but maybe. No, just use the squares in your book, because I don't have a squared paper. All right, I'll give you a second just to complete that diagram. That's okay. You don't have to do it the full size of the page if you don't want to. You just it's just a little sketch. And this thing is called the Cartesian plane. It is, or coordinate diagram sometimes. Sometimes people just call it the XY axis. All right, we usually plot coordinates on this plane. So over here, we can plot coordinates. So let's look at 3, 2. That is how we write a coordinate. That refers to an exact point on my Cartesian plane. The first number refers to the x-axis, and the second number refers to the y-axis. So it's 3 on the x-axis and 2 on the y-axis. So I go and find 3 on the x-axis here. And then I need to find 2 on the y-axis. And where these two would meet in space here, that is the point 3, 2. Now, I am presuming that you've done this before, so I'm not going to take too much time on it. I'm going to put a dot on this diagram, and you're going to hopefully tell me in the chat what is the coordinate of this dot. What is the coordinate of that dot? Perhaps you can put it in the chat. Yeah, a few people have it. Try to use brackets. So it's -3 on the x line and 1 on the y line. So -3, 1. What about if it's perfectly on the axis here? What's that one called? It's on the x-axis. What's it called? Yeah, you're getting this. So it's 4 on the x-axis, and it hasn't gone up or down, so it's just 0 on the y-axis. So it's 4, 0, yes. Okay. And the point down here, maybe that's the last one we'll do. What's that one called? This point down here. Oh, it is 0 on x, because it hasn't gone anywhere on the x-axis. It's in the middle, but it's down 3 on y. Okay, 0, -3. Okay, so try and put those points on your diagram as well. Those 4 points. I'll give you about a minute to do that. This is 3, 3. No, I think it's 3, 2. Might be on your diagram, but not mine. Okay, another second or so, and then I'll move on to the next thing. All right. All right, so we're going to look at two of those transformations we talked about at the start. If you remember, we're going to just look at translations and reflections. So usually we use the Cartesian plane for all this. We're going to use it, so we're going to have to draw another one, I'm afraid. Or you can use the same one you have drawn, it's up to you, to discuss translations. We won't draw one for reflections, so either draw a new one, the same size, pretty small, doesn't need to be that big. I'm going to draw a new one, or you can just use the one you already have and draw on it. Okay, so I've drawn my X and Y. Now you use the boxes if you're drawing a second one. If not, just it's perfectly fine to use the one you already have, because we're only going to put a little bit of information on this. I just want to show it clearly. Shouldn't have done that. I don't think I spaced them very well, but anyway. Okay, so I have my x-axis, usually just put an x here, and a y-axis, usually just put the y for short. All right, so now I'm going to put a shape on this, and I'm going to translate it. So remember translations from the previous page. Translations all about moving up, down, left, right. Okay, so I'm going to put a shape in here. It's going to be a square. So hopefully you can see those coordinates. It's at -3, -2. You can just put it in your previous diagram if you want. There. And I'm going to put another square. I'm going to put, yeah, it'll come good. Put the other one up here. Okay, so this is my object. This is my image. If we want to use letters, A, if the object is called the square A, the image would be called A with a little dash on it. A little dash there for A. Okay, so the question here would be, yeah, the internet's coming and going here. For some reason. Okay, so I've had to switch to my cell phone data. Is it clear now? Yes, okay, so the school Wi-Fi seems to be gone down. All right. Okay, so the question here would be, what is the translation from the object to the image? How did I get from A to A dash? So I just need to use left, right, up, down here. So I've clearly gone that way for a bit, and then I've gone that way. Or I've gone up and right, one or the other. Okay? So if I'm going right and up, this Wi-Fi is coming in and going. All right, right and up. I need to know how far right and up I go. So how far right and up? Can anyone maybe type in the chat or turn on the microphone? How far on my diagram? So I need to pick a vertex or a corner of the shape. So it doesn't matter which one I pick. Let's pick this one down here. It moves to here. So it takes 1 box, 2 box, 3 box, 4 boxes right. So 4 right. And then it goes up straight up from here. 1 box, 2 box, 3 box, 4 box, 5 up. Now, yeah, so you don't add them together. No, there's 2 separate directions. One's an X direction, left and right, and the other is a Y direction, up and down. So we can actually just shorten that to 4 or 5U, and that's a short way of writing that. And that is how I get from the object to the image. So it isn't that complicated, it's just the direction it goes. So if it was left, it'd be L, and if it's down, it's D. This one goes right and up. There is a way of doing this using something called vectors. Now, we're not going to use it this year. It's just a side note. If you want to put it in, you can. This written as a vector is 4, 5, like that. And if it was left 4, it would be -4. And if it was down 5, it would be -5. Up and right is positive, and left and down is negative. But that's just a side note. We're going to use this for this unit, just with the letters. When you get to year 8 and 9, you'll start using the vectors, but not yet. Okay, so that's translation. That is describing a translation. Key things here, just a reminder, the original thing is called the object, and where it has moved to is called the image. If you're using a letter, it is A and then the A dash. And we use this notation to describe, this is a description of the translation. Okay. Reflections now. Okay, so I know there's a lot of note taken, but unfortunately, geometry at this stage, you have to build up all your skills before you can start to solve problems. Problems are a bit too easy otherwise. You have to have a number of different techniques. So, reflections. So for this, I'm not going to use a Cartesian plane. You don't need to either. But maybe just make this 4 boxes, this triangle, maybe 4 boxes this way and 2 boxes this way, just so scale, so pretty small. 4 boxes, 2 boxes up, and then join the 2 corners. And then put a dotted line, maybe 2 boxes away. So maybe we can all try that. So 4 boxes in length here, 2 up, and then put a dotted line. Try and use a ruler. I know I didn't. 2 boxes away. So, as we've already discussed on the previous page, this dotted line, when I introduced it, is called the mirror line. And that is what this shape is looking at itself in the mirror. This is the mirror. It's looking at itself. It wants to see its reflection over here. So maybe you can try and draw it, but I'm going to take you through it. For this, we need to move these vertices one by one. In case you can't remember, a vertex or vertices. That's a corner of a shape. So if I do say vertex or vertices, that means a corner of a shape. All right. So what is this guy going to look at itself? Well, this dot will look at itself in the mirror, and it'll be the same distance away on the other side. So if you've used 2 boxes away, put it 2 boxes away on the other side. I estimated for that one. I'm going to actually use my ruler for the next one, just to make sure. Now, you can use something called a set squares to make it, because if you notice, these have to be right angles. You look at yourself straight in the mirror, you can't, there's no other way of looking at yourself in the mirror. You're looking straight at it. So this one is about 4.9 centimeters away. I'm looking at this top vertices here. It has to be the same distance the other side. So I'll put it the same distance the other side and try and keep a straight line going. So let's do that. And then keep that straight line going. Another 4.9 the other side. Oh, a bit off. My dots aren't great, but it's about here. Okay. You can just use boxes. That's why I'm using a ruler, just to make it absolutely clear. But you just count the boxes. I think this one should be 6 boxes away. And then this, its buddy, should also be 6 boxes away from the mirror. Now you probably could finish off the shape. This one should be in line with this. And then complete the shape. And you can see that it's kind of backwards. It's looking at itself kind of backwards. These dotted lines are called construction lines. They can be pretty light, especially for an easy reflection like this. It's just a cross line. You probably don't, and you have your squares, you probably don't need them. But when you're doing geometry and you put in lines that help you draw a shape, they're called construction lines. And if we wanted to give this a letter, let's say that was B, then its buddy over here is going to be B dash. And the original is called the object, and its buddy is called the image. Okay, so I'll give you a second just to tidy up your diagram before I do one final example, and then that's the last one. One more example. Yeah, that's construction lines, yeah. The little dotted lines, construction. Okay. One more to do. All right. So the mirror, this is not focused yet, but it will. The mirror isn't always straight down. It's not always perpendicular. Sometimes, just to be awkward, isn't there 2 more what? 2 more types? No, we're not going to get through them all today. It's a long process. There's a lot of theory in this unit, unfortunately. Or fortunately, if you like theory. All right, I want you to draw another shape. This time it's going to be an upside down T. So we'll try and get everybody the same measurements. So draw your line 6 boxes across. 2 in, 2 in. I'm going to try, yeah, it's hard for me because I don't have boxes, but I don't want to make it too big for the screen. And then 2 up. 2 up. Not wonderful. So this line is 6, 2, 2, 2, 2, 2, 2, 2. So hopefully you can draw that. Hopefully that made sense. 6 boxes across, 2 up, 2 there, 2 there, 2 there, 2 boxes, 2 boxes, 2 boxes. Brings it back. Should bring it back. It doesn't have to be perfect. Now, my mirror line is going to go like this. There you go. A diagonal mirror line. Oh no. All right. Now, if you feel like having a little go at trying to sketch this, you're more than welcome to. And we'll see how well you do. Or you can just wait for me to do it. So it's up to you. The other one is the probably proper note. This one is a bit tricky to get it absolutely right. So I put in dots for all my vertices, all my corners of this shape. I kind of have to move them all one by one. Remember, if you look in the mirror, if this dot is looking in its mirror, let's just do the one most closest. And you really need a ruler for this one. Perhaps I'll switch to a pencil in case I make a mistake. This dot looks at itself here, and it's 0.7 centimeters or 7 millimeters away from the mirror. So its image must be the same. So I'm going to draw some construction dots, 0.7. And then I'm going to move my ruler and continue with a straight line, make sure it's perpendicular, and put more, and then at 0.7, I'm going to put a dot. And that's just this one looking in the mirror. And you can see that makes sense. That's straight line, that's a right angle, and everything's good. That's okay. Now, everybody's going to be different because I didn't tell you how close to draw the mirror line. But you can just do. So this is why you need the ruler. Yeah, everybody's going to be different. How did you predict how close mine was? All right, so that's that one drawn. Now this one, I'm going to do this one next. Make sure it's 90 degrees, so as close. So 90 degrees is a bit of an estimation. If you have something called a set square, which is that, you know, that, oh, focus. Set square, I'm just going to put down here. If you have this shaped thing, you may have seen that with the measurements here. That's called a set square, and that makes a perfect right angle when you go to. So maybe you can use that, and I might need to show you in class. Well, it's very hard for me to show you without one here. Okay, but I'm just using a ruler. Okay, so I'm just measuring the distance. Perhaps you can see, well, this is 1.5 centimeters away from the mirror. Now, instead of me moving the ruler and continuing the line, I just know 1.5, and it would be double the other side then. 1.5 and add another 1.5 is going to give me 3. So I'm just going to go to 3. Now, you could just measure twice, but I think the logical among us will see that it's just going to be 1.5 and then another 1.5, so a total of 3. All right, so that's my first 2 done. All right, let's do this one that's really far away. This one over here. All right, so make sure I'll try and make, so I'm looking to try and make a 90-degree angle here without my set square. I don't have one, so try to make a 90-degree angle. And then this is about 4.5 centimeters away, so I'll draw my construction line. And if I go 4.5 the other side, I think it'll end up at 4.5 plus 4.5. That's 9, isn't it? Here. Okay. It's kind of weird looking. It's kind of weird looking to have a dot all the way down there. Anyway, let's just continue on with the process, and I will trust my process. Let's use this one now next. Try and make my 90-degree angle. It's 5.2 centimeters away on my diagram. Okay. So I'm trying to draw these construction lines nice and neat. 5.2, another 5.2. I think it's 10.4 if I go all the way. Keep the construction line. Oops. Keep the construction line. Okay, 10.4. Lovely. Okay, around there. Okay. Well, I know that there's a straight line between this dot and this dot. So there has to be a straight line between its buddies, this dot and this dot. So maybe I'll put in that straight line. You don't have to do it yet, but you can see I'm slightly off here. Yeah, you're gonna look wonky. Some of them will look wonky. You can see mine are just slightly off. Yeah. That's why you need a set square and be very accurate in your measurements. All right, but keep going anyway. I'm just gonna finish this off now. This is about 4 centimeters away. I'm estimating a 90-degree angle again. 4 centimeters away, so that means its buddy over here is going to be, keep going, add another 4. It's going to be at 8 centimeters away. And I'll do one more. I think, I need loads more. My goodness. This one, construction lines kind of help me remember which ones I haven't done yet. That's 4.8. So double 4.8. 9.6 I'm looking for. There. 9.6 away. Keep going. I need to do this one next. Through the mirror, try and line that up. That's about 3.4 away. Double 3.4 is 6.8, I think. That's going to end up around there. And I can kind of figure out my other one's going to end up here, but I'll do it anyway. Well, this takes a while, doesn't it? So, that's 2.7, double 2.7, 5.4. Okay, right here. Yeah, it's going to be messy. It's going to be messy. Definitely your first attempt. Okay, so I'm going to finish this diagram off with my ruler. Oh, see, I've definitely, I'm going to say, I'm just going to adjust these dots slightly because I can see that they're slightly off. And this is my attempt at drawing this without a set square. Okay, so that is my attempt. So it's not too far off. And all those construction lines are there. Perhaps if you want, you can call this image C then, because we've used A and B, and this can be C dash. This is the object. This is the image. Now I know most of you guys probably have maybe made a little bit of a mess of this, but that's okay. First attempt at a diagonal one is really hard. Okay, but okay. The key thing here is that these lines must be perpendicular. It must be perpendicular here. Now, when I say perpendicular, I mean right angles. It's got to meet, these construction lines have got to meet the mirror line at a right angle. Okay? All right. So this one will kind of be the rough note. Hopefully the one with the triangle that you've done on the other page is that I've done here is the better note. But this one, that's my attempt at drawing a difficult reflection in a diagonal line, which is always a challenge, no matter who's doing it. So the more time you take and the slower you do it, generally, the neater and better it is. Thank you for telling me I'm muted. I pressed the mute button. Okay, so that's a lot of notes taken for today. There is no other work, so just make your note neat and tidy. When you're finished taking this note, you're more than welcome to leave the meet, and we'll take it up here tomorrow with some questions where you'll do it, and perhaps me and Miss Whittian will give you some help. So if you've taken your notes and you don't need to see any other notes, you can now